Hello everybody, welcome into another lesson. So today we are going to solve combined inequalities. This right here is an example of a combined inequality. You have, as an example, negative 3 is less than t, which is less than or equal to 2. So what this really means is that t is greater than negative 3, but t is less than or equal to negative 2. So it tells you that the value of t is somewhere between negative 3 and 2. So this is what's called a combined inequality. When you have two inequalities with the same variable combined into one sentence. So let's do our first problem here. We have negative 2 is less than a plus 1, which is less than 3. So we have negative 2 is less than a plus 1, which is less than 3. Well, how do we actually solve? Well, all you have to do is you want to get a by itself, so you got to subtract 1. So all you're going to do is subtract 1 from each of these numbers on either side of the a plus 1. So if I subtract 1 from negative 2, I'll get negative 3, which will be less than a, which will then, if I subtract 1 from 3, I'll get 2. So I end up getting negative 3 is less than a, which is less than 2. And now the next step is to graph this. So you're going to draw a number line. Draw yourself a nice number line. Let's see, I'll put negative 4 here, negative 3 here. I'll put positive 3 here, positive 2 here. Alright. Negative 2, negative 1, 0, and 1. So draw a good representative number of samples. Then you're going to graph this. Well, how do you graph a combined inequality? Well, negative 3 starts where it's going to be, and since it's less than a, you're going to put an open parenthesis, but that open part of the parenthesis will face to the right. The open part of the parenthesis faces to the right, and then since it's less than 2, that means you'll put another open parenthesis at 2, but since that's your second number, you'll put the open part of the parenthesis facing to the left. And then what you're going to do is just shade the region between negative 3 and 2. Because since it's less than, we don't want to include negative 3 or positive 2. That's why we have a parenthesis. So you shade the region between negative 3 and 2 after doing the parenthesis, and that's the graph of the combined inequality. All right. Next up, let's see. Negative 2 is less than y minus 2, which is less than or equal to 1. So, we have the combined inequality of negative 2 is less than y minus 2, which is less than or equal to 1. Well, again, we want to get y by itself, so you're going to have to add 2 to both of the numbers on either side of the y minus 2. So if I add 2 to negative 2, I'll get 0. That'll be less than y, since I add 2 to that, which will be less than or equal to 1 plus 2, which is 3. So I get 0 is less than y, which is less than or equal to 3. That would be the solution. Now for the last part of this, I need to graph it. In order to graph this, let's see, 0, 1, 2, 3, 4, 5. I'll do negative 1 here, negative 2 here. Try to get a good representative sample. So let's see, the combined inequality starts at 0. 0 is simply less than y. So I'm going to use a parenthesis at 0. Since it's the first number, the open part of the parenthesis is going to face towards the right. Now, y then is less than or equal to 3. So at 3, I'm going to put a bracket since it has the equal component. I'll put a bracket at 3. So you have a parenthesis on 0, and then a bracket at 3, and then you still just shade the region between 0 and 3. So the bracket denotes that the solution includes 3. That's why we use a bracket instead. So that's how you would graph the solution of 0 is less than y, which is less than or equal to 3. All right. -4 is less than -3 plus d, which is less than or equal to 2. So I have -4 is less than -3 plus d, which is less than or equal to 2. Okay. Well, we still want to get that d by itself, right? We have a -3, so we need to add 3 to both numbers on either side of the -3 plus d. If I add 3 to -4, I get -1. That'll be less than d, which will be less than or equal to 2 plus 3, which is 5. So the solution to this is going to be -1 is less than d, which is less than or equal to 5. And then now I just got to go through and graph this on a number line. Let's see. -2, -1, 0, 1, 2, 3, 4, 5, and then 6 will go right here. Alright, so I have a good representative sample of numbers. Now it starts with -1 is less than d, so since it's just less than, you'll put a parenthesis at -1, the open part of the parenthesis facing towards the right. And now since d is less than or equal to 5, at 5 I'll put a bracket, but the open part of the bracket facing towards the left. And then I'll just simply shade the region between -1 and 5. That's all I'm going to do. I'll shade the region between -1 and 5 there. And that would be the solution. That would be how you graph it. Let's see. -6 is less than or equal to 3 plus r, which is less than 4. So we have the combined inequality of -6 is less than or equal to 3 plus r, which is less than 4. Well, want to get r by itself, so I need to subtract 3 from everything. If I subtract 3 from -6, I'll end up getting -9. That'll be less than or equal to just r, which will be less than 4 minus 3, that's 1. So the solution itself is -9 is less than or equal to r, which is less than 1. Now for the last step, I need to graph this. I'm going to draw a nice long number line because we have a lot of numbers. Alright, I'll put -10 right here, -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, and then 2. Alright, so my number line goes all the way from -10 to 2. So now we start with the first number. -9 is less than or equal to r. So since it's less than or equal to r, that's going to be a bracket at -9, since it's got the equal component. So the open part of the bracket will face to the right. So draw a nice bracket at -9. And then since r is less than 1, at 1 you'll put a parenthesis since it's just less than 1, because we don't want to include 1 in the solution. But the open part of the parenthesis will face towards the left. So then, of course, between -9 and +1, you're going to shade the entire region. And that would be how you graph the solution, with a bracket at -9 and a parenthesis at +1, and then you shade the entire region. Alright, let's see. -2 is less than or equal to 2a plus 4, which is less than 8. Alright, so this time we have a multiple of a variable. Well, what we're going to do still, we want to start out getting that 2a by itself. We need to subtract 4 from all these sides. So if you subtract 4 from -2, you get -6. That'll be less than or equal to 2a, since you subtracted 4 from that, which would just be less than 4, since you subtracted 4 from 8. So now you're down to -6 is less than or equal to 2a, which is less than 4. However, we just want to get a by itself. Well, this also works with division and multiplication. You want to divide all the sides by 2. If I divide -6 by 2, I get -3 will be less than or equal to a, which will be less than 2. So the solution is going to be -3 is less than or equal to a, which is less than 2. And now, of course, we close it off with a nice graph. Alright. -5, -4, -3 right there. -2, -1, 0, 1, 2, 3, and 4. Alright, so I have a good representative sample of numbers. So -3 is less than or equal to a. So since it's less than or equal to a, it gets a bracket. And since it's the first number, it's to the left of the a, the open part of the bracket will face to the right, because we want to include -3 in the solution, since it's less than or equal to a. Now a is just less than 2. Just less than, it gets a parenthesis at 2, and the open part of the parenthesis faces to the left. So you'll put your bracket here, parenthesis there, then you'll just shade the region between. The shading denotes that it's all numbers, that the solution is all numbers between -3 inclusive to 2 non-inclusive. That's what the shading represents. Alright. See, -2 is less than 2b minus 1, which is less than or equal to 5. Okay, so we have the combined inequality here of negative 2 is less than 2b minus 1, which is less than or equal to 5. Well, I want to get the 2b by itself, so I need to add 1 to all these sides. If I add 1 to negative 2, I'll end up getting negative 1. That'll be less than 2b, which will be less than or equal to 5 plus 1, which is 6. Well, I have 2b, I just want to solve for b. So I have to divide everything by 2. If I divide negative 1 by 2, I get negative 1/2. That'll be less than b, which will be less than or equal to 3. So the solution to this would be negative 1/2 is less than b, which is less than or equal to 3. Now for a final step, I got to graph this. So let's break this out here. Shouldn't need to be a big number line. Negative 2, negative 1, 0, 1, 2, 3, and then 4. Okay. So to start with, I have negative 1/2 is less than b. So it's just less than b. So that means it gets a parenthesis at negative 1/2, which would be right about here between 0 and negative 1, halfway between them. So I'm going to put in a parenthesis at negative 1/2 where the open part will face to the right. And then since b is less than or equal to 3, I will put a bracket at 3 where the open part faces to the left. And then I'll just shade the entire region between. And that's how you would graph it. Alright, negative 5 is, whoops, why am I writing negative 3? Excuse me. Negative 5 is less than or equal to 3m plus 1, which is less than 4. Alright, so this combined inequality, we're given negative 5 is less than or equal to 3m plus 1, which is less than 4. Well, we want to get that 3m by itself, so that means we need to subtract 1 from everything. So if I subtract 1 from negative 5, I end up with negative 6 would be less than or equal to the 3m, which would just be less than 3. So now I have negative 6 is less than or equal to 3m, which is less than 3. Well, ultimately, I just want to get m. So I need to divide everything by 3. I divide negative 6 by 3, I'll get negative 2, which will be less than or equal to m, which will be just less than 1. So the solution to this is negative 2 is less than or equal to m, which is less than 1. And then the final step, I need to graph this. Alright. Let's see, I'll put negative 3 there. Negative 2, negative 1, 0, 1, 2. Alright. So now I have a good representative sample of numbers on the number line. So negative 2 is less than or equal to m. So since it's got the equal component, I'll put a bracket at negative 2 where the open part of the bracket faces to the right. And since it's just less than 1, m is just less than 1, I'll put a parenthesis at 1 where the open part faces to the left. And then I'll just shade the entire region in between. And that would be it. That's all there is to it. All right, negative 8 is less than 3n plus 7, which is less than or equal to 1. Alright, so for this combined inequality, we have here negative 8 is less than 3n plus 7, which is less than or equal to 1. Well, we want to get the 3n by itself, so we got to subtract 7 from everything. If I subtract 7 from negative 8, I get negative 15. That'll be less than the 3n, which will be less than or equal to, you have 1 minus 7, that would give you negative 6. So now you got negative 15 is less than 3n, which is less than or equal to negative 6. And of course, I just want to solve for n, so I got to divide everything by 3. I divide negative 15 by 3, I'll get negative 5, which will be less than n, which will be less than or equal to negative 6 divided by 3, that'd be negative 2. So the solution ends up being negative 5 is less than n, which is less than or equal to negative 2. And now for the final step, we graph. So, let's see here. Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. I'll put 0 here, and I'm going to extend this line a little bit. Well, actually, I don't need to. It's negative 2. I was thinking I had to go to positive 2 for some reason. Excuse me. Okay. So, since negative 5 is just less than n, it's only less than, you put a parenthesis. Again, a parenthesis means you're not including that number, but you put it at that number. So the open part of the parenthesis will face to the right. And then n is less than or equal to negative 2. So since it's got the equal component, you put the bracket at negative 2. The bracket denotes we are including that number in the solution. So the open part of the bracket will face to the left. So now we're just simply going to shade the region to denote that it's all numbers between negative 5 up to and including negative 2. And that's how you would graph the solution set on a number line. Alright, so what we've been doing here are called conjoint sets. Conjoint, you can think of it conjunction. So let me write that here. We have done what are called conjoint. You could think of it, as conjunction. They include the word and. And then such examples as negative 2 is less than x, which is less than 3. Since they're a combined inequality, that's considered a conjunction, a conjoint set. What we are about to talk about for some examples here are disjoint sets. So we will talk about disjoint, disjunction. They will be disjunctions. They will use the word or, which you will see in the following examples here that I'm about to give. They'll use the word or. And we graph those a little bit differently. You're going to see just how. So, we have y minus 2 is less than negative 5 or y minus 2 is greater than positive 5. So this is a disjoint set because you have y minus 2 is less than negative 5 or y minus 2 is greater than 5. So you're going to solve these problems largely like you would solve a normal inequality. Focus on one at a time. So you want to get the y by itself, you have y minus 2 you need to add 2. So if I add 2 to both sides of this inequality, I'll get y is less than negative 5 plus 2, that'll be negative 3. So y is less than negative 3, or now you want to solve for y when you got y minus 2 is greater than 5. Well, you add 2, you'll get y is greater than 5 plus 2, which is 7. So you have y is less than negative 3, or y is greater than 7. That's your solution. Now, how the heck are you going to graph something like that on a number line? Well, there is a way. Get a good representative sample. All right. Let's put negative 5 there, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. So I have the numbers negative 5 through 8 represented on this number line. So start with your first one. Y is less than negative 3. So pretend y is less than negative 3 is your only solution. If it's less than negative 3, you're going to put a parenthesis at negative 3 because the solution does not include negative 3. And since it's less than negative 3, you're going to make the open part of the parenthesis face all numbers smaller than negative 3. So you got a parenthesis at negative 3 because we don't want to include negative 3 in the solution. The open part of the parenthesis faces all numbers smaller than negative 3. Then you just simply shade the entire region, which really this goes from negative infinity to negative 3. That's what that really goes from, which we'll get more into that another time, but just focus on now the parenthesis from negative 3 to the left. Now we've answered that part of the graph. Now we have to deal with y is greater than 7. So since it's just greater than 7, we'll also put a parenthesis at 7. But since it's greater than, the open part of the parenthesis will face to the right towards all numbers bigger than 7. Then you'll shade the entire region from 7 on up, which would really give you 7 to infinity. So yes, you have a disjoint graph here. You got from negative infinity to negative 3. None of the numbers in between negative 3 and 7 are included. Those aren't part of your solution set. Then you have from 7 on up, from 7 to infinity. So that would be how you graph a disjoint set. And I got some more examples here. I do got more. All right. We have h plus 5 is less than or equal to negative 2, or h plus 5 is greater than or equal to positive 2. So we have here another disjoint set. H plus 5 is less than or equal to negative 2, or h plus 5 is greater than or equal to 2. So again, focus on one inequality at a time, okay? So you're going to you want to get h by itself, so subtract 5 from both sides. If you do that, you'll get h is less than or equal to negative 2 minus 5. That'd be negative 7. So you'll have h is less than or equal to negative 7, or you want to now do h plus 5 is greater than or equal to 2. So you want to subtract 5 from both sides. You'll get h is greater than or equal to 2 minus 5, which is negative 3. So your solution ends up being h is less than or equal to negative 7, or h is greater than or equal to negative 3. All right. Now we have to graph. All right, let's see. Negative 9 I'll put there. Negative 8. Negative 7. Negative 6. Negative 5. Negative 4. Negative 3. Negative 2. And then negative 1. All right. So I have a very good representative sample here. So let's start with h is less than or equal to negative 7. Since it's got the equal component, it gets a bracket instead of a parenthesis. It gets a bracket. So you'll put a bracket at negative 7, but since it's got the less than component, the bracket, the open part of the bracket, will face all numbers smaller than negative 7. So that means it's going to face to the left. That's where the bracket would face. And then you would just shade the entire region from negative 7 onward. Now we've answered that part. Now we have to deal with h is greater than or equal to negative 3. So at negative 3, you're going to put a bracket there because there's the equal component. But since there's the greater than component, the open part of the bracket's going to face all numbers bigger than negative 3. So put a bracket there, and then you just shade the entire region from negative 3 onward. And that would be how you graph such an inequality, how you graph the solution. All right. Let's see, 2x plus 1 is less than or equal to negative 3, or 2x plus 1 is greater than or equal to positive 3. So for this particular inequality, we have 2x plus 1 is less than or equal to negative 3, or 2x plus 1 is greater than or equal to positive 3. Well, again, take this one inequality at a time. So let's start with 2x plus 1 is less than or equal to negative 3. We want to get the 2x by itself, so we have to subtract 1 from both sides. If we do that, we get 2x is less than or equal to negative 3 minus 1. That's negative 4. Okay. Then keep your word or. When you're doing the work, you want to keep it kind of in line. Keep it kind of together. Now we'll deal with 2x plus 1 is greater than or equal to 3. Well, we want to get 2x by itself, so we got to subtract 1 from both sides. If you do that, you'll end up getting 2x is greater than or equal to 3 minus 1, which is 2. So now you have 2x is less than or equal to negative 4, or 2x is greater than or equal to 2. Last step, of course, is we want to just solve for x, so you got to divide both sides by 2. If you do that, you get x is less than or equal to negative 4 divided by 2. That would give you negative 2. So x is less than or equal to negative 2, or then you have 2x is greater than or equal to 2. Divide both sides by 2. You would get x is greater than or equal to 1. So your solution to this is going to be x is less than or equal to negative 2, or x is greater than or equal to 1. Now for the final step, we need to graph this. All right. Let's put negative 4 there, negative 3, negative 2, 1, 0, 1, 2, 3. All right, so we have a good representative sample of numbers. Now, we'll start with x is less than or equal to -2. Since it has the equal component, it gets a bracket, which means we're going to include -2 in the solution. So we'll put a bracket at -2, but since there's the less than component, the open part of the bracket faces all numbers smaller than -2. So it's going to look like this. Put your bracket there at -2. Then you'll shade the entire region to the left of -2. All right, we've dealt with that. Then we have to address x is greater than or equal to 1. Well, since it has the equal component, it also gets a bracket at 1, but the greater than component dictates that the open part of the bracket faces all numbers bigger than 1. So the bracket will face to the right in this case. Draw your bracket at 1. Then you're going to shade every number from 1 on. You'll shade the entire region from 1 on. And that's how you would graph that set, the solution to that. All right, let's see. 1 plus 2y is less than -9, or 1 plus 2y is greater than 9. So we have here these disjoint inequalities of 1 plus 2y is less than -9, or 1 plus 2y is greater than +9. Take this one step at a time. We want to just get 2y by itself, so you got to subtract 1 from both sides. If you do that, you'll get 2y by itself. That'll be less than -9 minus 1. That turns into -10. So you'll have 2y is less than -10, or move on to your other one. Again, you want to get the 2y by itself, so you have to subtract 1 from both sides. If you do that, you'll get 2y, which would be greater than 9 minus 1, which is 8. So now you are down to 2y is less than -10, or 2y is greater than 8. Then, of course, you want to just solve for y, so you have to divide everything by 2. If you do that, you'll get y is less than -5, or now you do 2y greater than 8, so that would give you y is greater than 4. So your solution to this is going to be y is less than -5, or y is greater than 4. Make sure I have nothing important. All right, last thing, we're going to graph it. So, might want to draw a big one here. Let's see. Put -6 right there, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Now let's extend this a little bit. Sometimes you got to extend it some. We'll put 5 right there. Okay. So, I have a good representative sample of numbers now on my number line, so I can go ahead and graph this. Start with y is less than -5. So it's just less than. That means we're not including -5 in the solution. So you're going to put a parenthesis at -5. And since it's less than, the open part of the parenthesis will face all numbers smaller than -5. So draw your parenthesis at -5. Then you're going to shade all numbers from -5 onward to the left. So there's that part. Now we have to deal with y is greater than 4. Since it's just greater than 4, that means we're not including 4 in the solution, so a parenthesis also will be placed at 4. But since it's greater than 4, the open part of the parenthesis will face all numbers bigger than 4. So let's go ahead and place the parenthesis there. And then we'll shade all numbers from 4 onward to the right. And that would be your solution for graphing that inequality, for the disjoint inequality. Alright, I think we only got a few more here. Good one. -6 is less than or equal to -x, which is less than or equal to 2. Well, this is interesting now. We have a -x in the middle of our inequality here, of a combined inequality. We want to just solve for x. Well, what you can do, since this is a combined set, it's a conjoined set, it's a conjunction. What that means is that you're going to have, since -6 is less than or equal to -x, which is less than or equal to 2, whenever you have a conjunction, you can actually split these up into separate pieces if you want. What I mean by that, start with -6 is less than or equal to -x. Since it's less than or equal to -x, that has to mean that -x is greater than or equal to -6. And since it's a conjoined set, you're going to use the word and. Then you'll get -x is less than or equal to 2. So now we've split these into separate sets, make it a lot easier to solve. So start with -x is greater than or equal to -6. Well, you divide both sides by a negative. What's going to happen is you'll get x, and then -6 divided by -1 gives you +6. But what you're going to have now, since you divided both sides by a negative, you flip the sign. So that greater than or equal to becomes a less than or equal to. So x will become less than or equal to 6. And we'll have -x is less than or equal to 2. So you divide both sides by a negative, you'll get x turns into greater than or equal to -2. So how this is turned, you end up having x is less than 6 and x is greater than or equal to -2. So you can leave your solution like that, or since we'll start with the smaller number, since x is greater than or equal to -2, that also means that -2 is less than or equal to x. And then we know x is less than or equal to 6, so we can combine that part. You could also write your solution as -2 is less than or equal to x, which is less than or equal to 6. So that's what you would get for your solution. You can either leave it as x is less than or equal to 6 and x is greater than or equal to -2, or you can write it as -2 is less than or equal to x, which is less than or equal to 6. And of course, then we'll graph it. Well, let's see here. We'll put negative 3 here, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. I'll even put 7 there. Okay, so we have from negative 3 to 7. We have a very good sample. So negative 2 is less than or equal to x. That part of it means you're going to put a bracket at negative 2 since it is being included in the solution because of the equal component. And that's your first number. So at the negative 2, the open part of the bracket will face to the right. And then x is less than or equal to 6, so you're going to put a bracket at 6 since you have the equal component, but since that's your second number, the bigger number, the bracket will face, the open part will face to the left. And then we will just shade the entire region in between. And that would be your solution. All right. I feel like we will do one more here. Negative 4 is less than or equal to 2 minus t, which is less than 3. Alright, so we're given negative 4 is less than or equal to 2 minus t, which is less than 3. Well, we should get that negative t by itself first, shouldn't we? So you'll have to subtract 2 from everything. If you do that, you'll end up coming up with negative 6 is less than or equal to negative t, which is less than 1. So now you have negative 6 is less than or equal to negative t, which is less than 1. Well, we have a negative on the variable, so we know it's going to be flipping some signs. To make life abundantly easier for yourself, what I'm going to suggest is that you go ahead here, split these up into separate parts. Since this is a conjunction, we can split them into separate parts. That means since negative 6 is less than or equal to negative t, that means negative t has to be greater than or equal to negative 6, right? And then we would end up having negative t is less than 1. Well, we'll start here. Negative t is greater than or equal to negative 6. Divide both sides by negative 1 to get the t positive. You'll get t turns that sign into less than or equal to 6. And then negative t is less than 1. Divide both sides by negative 1. You'll end up getting t, it turns that less than sign into a greater than negative 1. So what you have now is that t is less than or equal to 6, and it is greater than negative 1. So you can leave your answer like this, or if you like the combined inequality approach, you can put them back together. Since t is greater than negative 1, that means negative 1 is less than t, and then t is less than or equal to 6. So that would actually end up being your solution. Notice we even had some signs flipped. It flipped around the equal and not equal parts. So that is also why I highly recommend splitting these off into, whenever you're dealing with a negative variable, splitting them off into separate pieces. before you bring them back together, because it can get confusing. Alright, now we want to graph this. Let's see. Let's graph this. Let's see, we'll put -2 right there, -1 here, 0 here, 1, 2, 3, 4, 5, 6. Let me extend this one. Let's at least go to 7. I like to have a good representative sample. Alright, so we got from -2 to 7 on the number line. We're going to start with -1 is less than t. Since it's just less than t, you're going to put a parenthesis, so that denotes that you don't include -1 in your solution. So, put a parenthesis at -1, make the open part face to the right. Alright, there's the parenthesis. Now t is less than or equal to 6. That means since you got the equal component, you will actually put a bracket at 6. And since that's your bigger number, you will make the open part of the bracket face to the left. So, now that you've marked those areas, you're just going to shade the entire region between them. And that would be your answer. So that's how you do it. So complex inequalities can seem like a lot, but if you're dealing with or instead of and, you're dealing with disjoint sets, which means you're going to have graphs going on two different parts of your number lines where in the middle the solution's not joined. If you have and, that means it's a conjunction, which means you have a combined inequality. So that's what happens there. So the next lesson, we're going to get into absolute value equations and inequalities. So I hope everyone has a good night. Take care.